Thank you, grade 12. Welcome to your online learning. I thought we'd look at the workbook a little bit, maybe to help you get started. So chapter 5, properties of geometric figures. And what we want to do is we'll just go through a couple of examples and then you can maybe take off from there. So example 1, this is just good old grade 10, 11 trigonometry. We've got the sine, opposite over hypotenuse, cosine adjacent over hypotenuse, tan, opposite over adjacent. Remember that was, that was SOHCAHTOA. And you probably remember that from the last 2 years, right? So what they're doing is they're just warming you up to trig a little bit, and then what they're going to do is they're going to focus more on the properties of some of these shapes that contain triangles. So we'll see that in a bit. Let's just go through this though. So you can look at that, not a real big deal for you, probably really familiar. So here's one, page 176. We've got use the Pythagorean theorem to find the missing side length. So this would obviously be C, because it's across from the right angle, right? And so C equals the square root of A squared plus B squared. And that formula comes out of this. And you probably recall from a long time ago that if you take the square root of both sides, that would cancel out that, giving you C. And then I'm always putting brackets around there though, just in case my calculator does funny things with the order of operations. So that's that. If you want to quickly do it, you could, but you've got the answer key, so you can try it on your own. So square root of, so let's see here, 69.3 squared plus 47.6 squared. Let's see what we get. So 69.3 squared plus 47.6 squared. I'm in 84.1, and that would be my C. So that's that stuff, okay? So if we look through, let's go a little further. Let's see here, example 2, calculate the length. Now we're getting into some of those sine, cos, and tan things, but remember the strategy from last year is I always circled my angle, gives me a reference point, then I labeled with respect to what I saw from the angle, so that's adjacent, this would be hypotenuse, and therefore I would use cosine, and sure enough that's what they're using down there. This one here, I would find the measure of angle E, I would circle my E, then that would be opposite, that would be hypotenuse, so they're going to use the sine for that one, and you go down, have a little peek, sure enough, cosine like we thought, sine for that one there. Okay, next page, here, let's do number 2a. So solve for the length of side x. Again, I would circle so I can see where I am, that's opposite, that's hypotenuse, so that would be SOHCAHTOA sine, right? So sine of 27 equals x, opposite, over 2.8, and we can multiply that. So 2.8 times the sine of 27 is 1.27, or 1.3 centimeters. Okay, you'll notice one thing, I went 2.8 times the sine of 27, not sine of 27 times 2.8, so I'm just avoiding the use of brackets. And so if I went this way, sine of 27 times that, I would have to go brackets, close my brackets, you know, around there, because I don't want to find the sine of 27 times 2.8, right? So I'm just going backwards because of order of operations, if you're curious. And so that's that. This page is really familiar to you, I'm sure. So if we go to the next page, properties of triangles. So here's where it gets kind of weird, because we didn't do very much of this last year or in grade 10, but this year they're going way back to junior high, and they're saying, hey, what are properties that make these shapes what they are? And so here are some properties that you want to jot down in your study sheet. So I would really recommend that. Build your vocabulary, because these are going to pop up on those little 1-mark questions on your provincial, right? And so acute, angles are less than 90. Okay? Right angle. Well, we did lots of those last year. That's grade 10 and grade 11. That's all we did. So right angles. Obtuse, one angle measure is greater than 90. And you can see that, right? There's your measure. It's greater than 90. So obtuse sounds bigger than acute. Acute sounds small. It is. Obtuse sounds large. And that's how I remember these things, okay? So that's that. They're going to get into other definitions that you've probably got stored way back in your brains from junior high. Equilateral, equal, it sounds like equal. And so the cool thing is, not only are the sides equal, but the angles are equal as well. And remember the symbols, right? One little dash on each of those lines tells us they're all equal. And it's good to remember that kind of notation stuff, right? Isosceles is basically 2. So that one and that one are the same, okay? And then notice that angles opposite are also the same. That's kind of cool, right? Good to remember that. I'll do that up here as well. That angle corresponds to that side, that corresponds to that, that corresponds to that. So here's something to remember. Angles are somehow connected, I'm going to use that in quotes, to opposite sides. There is something about that. If you would increase the size of that triangle, let's say you were zooming in or zooming out, they maintain their connection together. That means that that has a connection to that, and that has a connection to that. There's something about them, and that'll become more important as we go along. Scalene, all sides are of different lengths, no angles are of equal measure. Okay, so that's something to jot down as well in your study sheet. What else do we have here? So here's one where you're given all this stuff, and now you're supposed to be able to find the length of something. So remember the notation. BC means from point B to point C. So I'm going to underline that, point B to C. There it is. That's what they want us to find. Okay, that's what that means. What's the length of that? This is kind of like grade 11 trig. You got 2 triangles. I would split them up and draw them separately, and that's the strategy we used last year, right? And then you put some stuff in that you know, x, and that's 20, and so now we can easily find that side of the Pythagorean theorem, right? And here on this one, we've got 53 degrees, we've got 16. We could find that one, C, again by using sine closer to 10. In this case, that's the opposite and the hypotenuse. We use sine. And you can run through that example on your own. And there it is. So have a peek at that. And we'll go on here. And there's your first question. So let's just try this one, and then we'll maybe let you try some on your own. So use the following diagram to answer the questions. What's the measure of angle M? Well, that's a good question. You'll notice these little symbols here, there, and there. That means the sides are the same, are equal. Okay? Well, if that's the case, then this one is also 15 meters. Now, if the sides are equal, then their corresponding angles, in other words, the connected angle, so if I just use blue for this one, that 15 is connected to the 60, and this one here is connected to that one there. Now, the cool thing is, if they're both 15, then their angles are also the same. So this is automatically 60 degrees. And if that's 60, and that angle is 60, well, you remember the rule, right? 180 degrees minus 60 equals the remaining angle is 60 degrees, which is there, 60 degrees. Now, the cool thing is, if all the angles are 60, that means all the sides are also the same, which means that this bottom side is 15 meters as well. Now then we'd want to show off our knowledge of triangle types, and we would say this is an equilateral triangle. Equilateral. And that is it for today.